some differentiation exam questions. In this question, the equation of a curve is such that dy by dx is equal to 6x squared minus 30x plus 6a, where a is a positive constant. The curve has a stationary point at a, negative 15. Find the value of a. So remember, at a stationary point, the gradient is always equal to 0. And we have an expression for the gradient here. Remember, dy by dx is the same thing as the gradient of the curve. So I'm going to start by putting this expression equal to 0. Okay, so that's the first step. So 6x squared minus 30x plus 6a equals 0, because the gradient is always 0 at the stationary point. Okay, so next I can substitute in the x-coordinate. Remember, the stationary point occurs at a, negative 15, so the value of x is a. Okay, so the next step I'm going to do is I'm going to replace the x values in this equation with the letter a, okay, since they're the same thing. As that will then give me an equation that just has a as the unknown value, which I can then solve, okay? So the first thing I'm going to do is simplify this equation. Here I have negative 30a plus 6a, which simplifies to negative 24a. So I'm left with 6a squared minus 24a equals 0. Now I can divide everything in this equation by the common factor 6. So that leaves me with a squared minus 4a. And now I have to solve this equation here. So to solve this quadratic, I'm going to factorize. So I'm going to factor out the common factor a. So a minus 4 goes inside the brackets. Okay, so if I'm solving this equation, there are two values of a. Either this value here is 0, or if the bracket is equal to 0, this value of a has to be positive 4, since 4 taken with 4 is 0. Okay, so we've got two values of a, but remember in the question it says that a is a positive constant, so a must be 4. In part B, we have to determine the nature of this stationary point. So is it a maximum point or a minimum point, for example? And to do this, we have to work out d2y by dx squared. So that just means differentiate dy by dx. So I'm going to start by writing down dy by dx, which is 6x squared minus 30x plus 6a. But before I differentiate, what I'm going to do is I'm just going to substitute in our value of a that we found earlier, which was positive 4. Okay, so this becomes 6x squared minus 30x plus 6 multiplied by 4, which is positive 24. Okay, so this is our expression of dy by dx, the gradient of the curve. So to work out d2y by dx squared, remember we're just differentiating dy by dx. So 2 multiplied by 6 is 12, so this term differentiates to 12x. Okay, remember the power always reduces by 1. This term, if I differentiate, I'm left with negative 30. And remember, if you differentiate a constant, this goes to 0. So this is our expression for d2y by dx squared, which we need to determine the nature of the stationary point. So you can see here, there's a value of x. So what I need to do is I need to substitute in the x value of the stationary point. And remember, we worked this out earlier. It was the value of a, which was positive 4. Okay, so we're going to replace this x value with positive 4. Okay, so now if I calculate that, 12 multiplied by 4 is 48. And 48 take away 30 is 18. Now, because 18 is positive, so 18 is greater than 0, we know that this stationary point is a minimum. next question, the equation of a curve is y equals k root 4x plus 1, take away x plus 5, where k is a positive constant. In part A, we need to work out dy by dx. So what I'm going to do first of all is I'm just going to rewrite the equation of the curve, writing it in its power form. So instead of using this square root symbol, I'm going to pop it into brackets and use powers instead, okay? So this equation would look like this. So y equals k, brackets 4x plus 1, close brackets, raised to the power of a half. Remember, this is the same thing as square rooting the brackets, okay? Minus x plus 5, okay? I just think it's just easier to see what we're doing when we differentiate if we write it like this first. So when we differentiate, so find dy by dx, what we need to do is take the power here on the brackets and multiply by this power. So a half multiplied by k is a half k. Then I write out the brackets as they are, so 4x plus 1, no changes here. And this power reduces by 1. So a half take away 1 is negative a half. And not forgetting to then also multiply what we've written down here by the derivative of what's inside the brackets. So if I was to differentiate this bracket here, okay, I would be left with positive 4 only. Okay, next if I differentiate negative x, I'm left with negative 1. And remember, if you differentiate a constant, you're left with 0. Okay, so now I'm just going to simplify. Okay, just tidy up what I've written down. So I can multiply a half here by 4. Okay, a half multiplied by 4 is just half of 4, which is 2. So I have 2k. Then everything else here stays the same. And I remember we're subtracting 1. Okay, so that's the answer. That's dy by dx. If you want, you could also rewrite it as a fraction, although you would get the marks for this. You could rewrite it as 2k over 4x plus 1, all square rooted, take away 1, and that is okay as well. In part B, we have to find the x-coordinate of the stationary point in terms of k. So remember, at a stationary point, the gradient is always equal to 0. And we just worked out dy by dx, which is an expression for the gradient, okay, of a curve. So we're going to take dy by dx that we just worked out, and it's preferable to take the form that I wrote down at the end of part A, so in its fraction form without the power, so using the root symbol. It's just easier to work with in the calculation, okay? So 2k over root 4x plus 1 minus 1 is equal to 0, okay? So the gradient is equal to 0 at the stationary point, okay? So we have to find the x-coordinate. So what we need to do here is rearrange this equation to make x the subject, okay? So that it says x equals on one side of the equation and everything else is on the other side, okay? So to start with, I'm going to add 1 to both sides of this equation. So by doing that, I'm left with 2k over root 4x plus 1 equals 1. Okay, next I want to get rid of this fraction here. So to do that, I'm going to multiply everything by this denominator. Okay, so I'm going to multiply by root 4x plus 1 throughout the equation. So if I do that on the left-hand side of the equation, this just cancels and I'm left with 2k, sorry. And if I multiply the right-hand side of the equation by this denominator, I'm left with root 4x plus 1. Okay, remember we're trying to get x by itself, okay, we're nearly there. So the next step is to get rid of this square root symbol. The opposite of square rooting is to square. So I'm going to square everything in this equation. So if I square 2k, it's like multiplying it by itself. So 2k times 2k is 4k squared. And if I square the right-hand side of the equation, it just cancels out the square root symbol to leave me with 4x plus 1. Okay, next I'm going to subtract 1 on both sides, so that 4k squared minus 1 equals 4x. And the final step would be to divide everything by 4, which leaves us with 4k squared minus 1 over 4 equal to x. So I've made x the subject, so this is the x-coordinate of the stationary point in terms of k. In this question, the diagram shows the points A and B lying on the curve, and the equation of the curve is here, y equals 9x minus 2x plus 1 in brackets raised to the power of 3 over 2. We have to find the coordinates of the maximum point of the curve in part A. So the maximum point, I've just marked here, okay, is at the top. And remember, at the maximum point, the gradient has to equal 0. So the gradient is the same thing as dy by dx. So the first thing I'm going to do is work out the dy by dx of this curve. Okay, so I'm going to write down the equation just below. So y equals 9x minus 2x plus 1 in brackets, raised to the power of 3 over 2. Okay, so when we're working out dy by dx, we're differentiating this equation. So if I differentiate 9x, I'm just left with 9. And if I differentiate this part of the equation, I must take the power here, so 3 over 2, and multiply by this power. So it's like saying negative 1 multiplied by this power is negative 3 over 2. Remember, the brackets remain the same, but the power here reduces by 1. So 3 over 2 is like 1.5. 1.5 take away 1 is a half. Okay, so the power changes to a half. Not forgetting at the end to multiply by the derivative of the expression inside the brackets. So if I differentiate 2x plus 1, I'm just left with positive 2. Remember, if you differentiate 1, you just get 0. And next, I'm just going to tidy this up, simplify. So I'm going to multiply these two numbers here together. Okay, so the 9 stays as it is. Negative 3 over 2 multiplied by 2 just leaves us with negative 3. And everything else here stays the same. Okay, so to help me with the next part, I'm just going to rewrite it not in power form. Remember that when you raise something to the power of a half, it's the same as square rooting. So I can rewrite this expression as 9 minus 3 square rooting 2x plus 1 here, okay? So that is the same thing, it's just going to be easier to work with in this form, okay? So remember I said at the beginning, at the maximum point, the gradient has to equal 0, which means dy by dx, which we just worked out, has to equal 0, okay? So that's my next step. I'm going to put this equal to 0. So 9 minus 3 root 2x plus 1 has to equal 0. And now if I solve this equation to work out x, it's going to give me the x-coordinate of the maximum point of the curve. Okay, so I'm going to start by adding 3 root 2x plus 1 to both sides of the equation. So I'm just moving this part over to the right hand side. So I have 9 is equal to positive 3 root 2x plus 1. Next, I'm going to divide everything in this equation by 3. So 9 divided by 3 is 3. 3 divided by 3 is just 1, so this cancels to leave me with root 2x plus 1. Next, I want to get rid of this root symbol. So I'm going to do the opposite, which is square everything in the equation. So 3 squared is 3 times 3, which is 9. If I square the right-hand side, it just cancels out the root symbol to leave me with 2x plus 1. Next, I need to subtract 1 on both sides. So 9 take away 1 is 8. 1 take away 1 is just 0, so that cancels to leave us with 2x. And the last step here is to divide both sides by 2. So 8 divided by 2 is 4. So there is our x-coordinate. Okay, so we're nearly there. We have to find the coordinates of the maximum point. So next we have to work out the value of y. So to do that, you need to take your x value and substitute it back into the original equation. Okay, so this up here. So I'm just going to squeeze it on here, hope you can see. So in this equation, y equals 9x minus 2x plus 1, all raised to the power of 3 over 2. I need to switch the x values for positive 4. So y equals 9 brackets 4 minus, in brackets, 2 multiplied by 4 plus 1 raised to the power of 3 over 2. So you could just put this in your calculator if you want to, or if you want to do it in your head like me. 9 multiplied by 4 is 36. Then inside the brackets we have 2 times 4, which is 8, plus 1, which is 9. And remember, you're raising it to the power of 3 over 2. So this is the same thing as square rooting what's in the bracket, so 9, and then raising it to the power of 3. Okay, does that make sense? So if I square root 9, I get 3. And then if I cube it, so 3 times 3 times 3, I get 27. Okay, so it's 36 minus 27. If you don't like what I just said, you could just put that in the calculator here, okay, and it will give you the value of y straight away. So 36 take away 27 is 9. So that is the value of y, and so the coordinates of the maximum point are 4, 9. In part B, we have to verify that the line AB is the normal to the curve at A. Okay, so here's the line AB. We need to check to see whether this is the normal. So is it a line that makes an angle of 90 degrees with the curve at point A? Okay, so what I need to do to start with is work out the gradient of the line AB. I also need to know the gradient of the curve at the point A. Okay, and with those two gradients, if I multiply them together and they equal -1, that will tell me that the line AB is the normal to the curve at point A. Okay, hope that makes sense. So I'm going to start by working out the gradient of AB, the line AB. So if I am working out the gradient of a straight line, I'm going to use that method rise of a run. So I'm calculating the difference between the y values of A and B and dividing that by the difference between their x values. Okay, so the y values of A and B are given in the question here. So I've got 5.5, so 5.5 minus 3.5, so 3.5. Divided by the difference in the x values, so 1.5, so 1.5 minus 7.5, so 1.5. Okay, so to work out the gradient of a straight line is the difference in the y values divided by the difference in the x values. Okay, so 5.5 take away 3.5 is 2, and 1.5 take away 7.5 is -6, and if I simplify this, 2 divided by -6 is -1/3. So first of all, there is the gradient of the straight line AB, okay? So next I need to know the gradient of the curve at the point A. So remember in part A, we worked out an expression for dy by dx. That is the gradient of the curve at any point, except we do have a point now. Remember, this is at point A, and at point A, we have the coordinates here, 1.5, 5.5. So what I can do is substitute the x coordinate of A into our expression here, dy by dx, to work out the actual gradient of the curve at point A, okay? So I'm just replacing the x value with 1.5, okay, as that is the x coordinate at point A. Okay, so dy by dx becomes 9 minus 3 rooting 2 multiplied by 1.5, so 1.5 plus 1. Okay, and now I'm just going to calculate this, okay? So inside the square root symbol, we've got 2 multiplied by 1.5, which is 3, and then we're adding 1 to get 4. Now, you know what the square root of 4 is. The square root of 4 is 2. So we have 9 minus 3 multiplied by 2. 3 multiplied by 2 is 6. So it's 9 take away 6, which is 3. So that is the gradient of the curve at point A. Okay, so we've got the gradient here of the straight line AB, the gradient of the curve. So the last step is to multiply the two gradients together. And if they equal -1, which they do, it tells us that this is the normal, so the line AB is the normal to the curve at point A.